Hey guys, and welcome back to Data Science, Logistic Regression in Python. In today's class, we're going to talk about linear classification in general. So let's talk about linear classification in its simplest form, a two-dimensional plane. We have a bunch of x's on the left and a bunch of o's on the right, and we would like to separate them. Of course, what we can separate them with is a line. So what is the equation of a line that we all remember from grade school? That's y equals mx plus b, where m is the slope and b is the y-intercept. Remember that the general form of a line is 0 equals ax plus by plus c, which of course can be rearranged to give you y equals mx plus b quite trivially. You can see that if our x's and o's are split along a 45-degree line that crosses the y-intercept at 0, then a equals 1, b equals -1, and c equals 0 should be the line. So in other words, our line is 0 equals x minus y. So now let's say we have a test point at x equals 2 and y equals 1. If we plug that into x minus y, we get h equals +1, which is bigger than 0. Therefore, we should classify this new test point as an O. Now let's say we have another point at x equals 1 and y equals 2. Should this be classified as an x or an O? So we again plug it into our formula for h. We get -1, which is less than 0, and so we classify it as an x. Now let's say we have a point at x equals 1 and y equals 1. Should this be classified as an x or an O? So this falls directly on the line. We can't really tell if it should be an x or an O. So this is the essence of linear classification. Our job is, we're given all the x's and the o's, and we need to find the a, b, and c, which define the line. So now let's talk in machine learning terms. We usually call x x1 and y x2, and we put this into a big vector called just x. We rename the a, b, and c constants to w sub I. We call the bias term or intercept w0, and we usually create a dummy variable x0, which is always equal to 1, and then we can form our hypothesis function h in terms of the vector x and the vector w. We can say that h is a linear combination of the components of x. In vector form, we can write w transpose x, which is the inner product of the vectors w and x. We also call this the dot product. Now, so what happens if we add more dimensions to this problem? So x3, x4, etc. So in 3 dimensions, our line will become a plane. And in greater than 3 dimensions, it will become a hyperplane. If we have a nonlinear, so not a line, function separating our data, we would call that a hypersurface. So I'm going to take this opportunity to let you guys know about my site. If you find any of the material in this course too challenging or you have questions, I'm always available to answer them, and I offer personal coaching as well. My site is at http://lazyprogrammer.me. There's a newsletter drop-down that should show up when you go there. If you sign up for my newsletter, you not only get a 6-week introductory course to data science, I also use it to announce when my Udemy courses and Amazon books are being given away for free. If you follow me on Twitter, it's at twitter.com/lazyscientist. I give out coupons there as well. And if you like my Facebook page at facebook.com/lazyprogrammer.me, I give out coupons there as well.